Okay, this is our 2014 Fall Final Exam Review, or the Algebra 1 midterm. We wanted to give the video so that the students could go over their review. They should have a copy of this review. We handed that out on Friday before they left for the weekend. And we wanted to get this video out there so that they could go over the review itself before they came into class on Monday and Tuesday. We will review some in class on Monday and Tuesday, and then the finals will be Wednesday, Thursday, and Friday, depending on their schedule of what class period they have Algebra 1. Alright, as with most of the videos, I'm going to move rather quickly. You'll have the ability to pause and rewind and go back over this. So for sake of time and video length, we'll go rather quickly through this. Again, most of these problems, again, we've been working on this for quite some time, so they should have a pretty good grasp on this. It's just a review, so let's get started. Evaluate the expression, part 1 here. We're going to evaluate 4 plus 9 minus 3 in parentheses times 2 squared divided by 2 times 6 minus 4 in parentheses. The first thing we do, obviously with PEMDAS, we're going to look at parentheses. So we'll take the 9 minus 3, that's going to be a 6. 6 minus 4 will be a 2. So we can rewrite this as 4 plus 6 times, and we have exponents here too. 2 squared is just 4. That's all over 2 times 2. Okay, we can finish that again in just a second. That will then become 6 times 4 will be 24. 24 plus 4 will be 28 on the very top. And then 2 times 2 is just simply 4. 28 divided by 4 is 7. So the answer to number 1 is 7. Moving down the page, we're going to look at number 2. We have absolute value signs. The lines here are just absolute value signs. We treat them like parentheses. We will start in the middle first and work our way outward. So we'll rewrite this as negative absolute value of negative 15 plus, and the innermost absolute value is this negative 9. Well, negative 9 absolute value is just simply 9. And then we'll put our absolute value sign on the outside. All right, now we'll work the inside just like we do parentheses. Negative 15 plus 9. This will become negative absolute value of negative 6. All right, now we know the absolute value of negative 6 is 6, and so this simply becomes a negative 6 because it's a negative absolute value of negative 6, so that's a negative 6. That's the answer to number 2. Moving down the page here, we will go to number 3, where we just simply simplify the expression. We're not solving for t, we're just simplifying the expression. Now, we have a method of writing terms when we have exponents, and generally we write the terms in order of the highest exponent to the lowest exponent. In this case, we have a t squared, and it's a positive t squared, and so we'll put that at the front. It's the only one we have in the expression, so that one's taken care of. Then we'll move on to the next exponent of t, which will be just t to the 1 power. We have a negative 8t, and we have a negative 7t, and if we put those two together, we'll end up with a negative 15t. Those are taken care of. And finally, we have the integer of positive 6 to add to that. So our answer should be t squared minus 15t plus 6. That's the answer to number 3. Number 4. This one we will simplify. Again, we're just simplifying, not solving for b. And we have a distribution issue here. We've got to distribute this negative 2, and I like to circle the sign with the number outside of parentheses, because we're actually distributing a negative 2 times 3 and negative 2 times 2b. We have to do that first before we can do anything with a 7, so we'll just bring the 7 down. A negative 2 times 3 will be a negative 6. Negative 2 times negative 2b will be a negative 4b. When we combine these like terms in front here, we're going to have 1 minus 4b. We can't simplify any further, so the answer is just simply 1 minus 4b. All right, moving on to number 5. Again, more simplification and more distribution. We have 3, there's no sign, so we take it as positive. 3 times 2r and 3 times positive p. This will become a 6r plus 3p. Now, we've also looked at this next part as having a negative 1 inside here, and you could distribute a negative 1 into this parentheses, or we also know that when we have a negative in front of parentheses, all we're doing is just changing the sign of whatever's inside. So we have a positive r, this will become a negative r. We have a negative 2p, the negative out front makes that a positive 2p. And now we can combine like terms. We have, again, circling the sign with its letter, we have a negative r and we have a positive 6r. So that would be 5r. We have a positive 3p and a positive 2p. That will give us a positive 5p. So the answer to number 5 is 5r plus 5p. Okay. Now we're going to move on to evaluating some expressions here. We're given negative a minus b plus y. Now before we do anything, I always like to rewrite that as a negative value of a, that way we can put it in parentheses, and minus value of b plus value of y. Okay? That said, the value of a is negative 3. Well, we just put it inside the parentheses. The value of b is a negative 2. We put that inside the parentheses for b. And the value of y is 5. Okay, now, negative negative is going to make that a positive 3. A negative negative 2 will make that a positive 2. And then we just have a positive 5. And when we add all those up together, we're going to get 10. So, the answer to number 6 is 10. Moving down the page here to number 7. Again, I like to start out by just putting parentheses where the variables are. That way we don't get our signs confused. And so this will end up being the value of c plus the value of b all over the absolute value of the value of a plus the value of b plus the value of c. Oops. Actually, the value of c, we'll just go ahead and make it negative 2 because I messed up and wrote c. And then we'll put the absolute value sign on the end. Okay, plugging these in, the rest of these in, we're going to have the value of b is 5. Almost wrote the letter again. And the value of a is negative 1. So we're going to have negative 1, 5, and negative 2. Clean that up a little bit. The top we're going to have c plus b. The value of c is negative 2. The value of b is 5. Okay, so negative 2 plus 5 is going to give us a 3 on top. Okay, and the bottom we have a negative 1 plus 5 is going to give us 4. 4 minus 2 will give us 2. We have the absolute value of 2. Well, that's just simply 2, so our answer is going to be 3 over 2 for number 7. Okay, moving on to properties. We have commutative, associative, and distributive properties. And we're going to label what's being illustrated here. We have 3 times a plus 2 times b, or 3a plus 2b. That's going to be equal to 2b plus 3a. This is addition. And we know that in addition, order doesn't matter in how you write the expression. When order doesn't matter, as the order changes here, they're still equal. That is the commutative property. All right. Next, we have 3 times, in parentheses, a plus 2. And then the next, that's going to be equal to, the next part here says it's 3a plus 6. Well, that's simply distributing the 3 into this parentheses. 3 times a would be 3a. 3 times 2 would be 6. So this is the distributive property. Okay, let's flip the page. And on the back, number 10, We have two more problems naming the properties here. 3 times 2 plus a and 3 times a plus 2. Well, we do have a group of integers here, but inside the group, we just changed the order. Okay, we've taken 2 plus a and a plus 2. And once again, if order changes, but it doesn't change the answer there. If order's changing, this is addition, so we know that it is commutative already. We change the order in both sides, answer should be the same. This is the commutative property. Number 11 says 3 times 2 in parentheses times a is equal to 3 in parentheses 2a. Now we've got a group of integers, 3 and 2, and then a. And then they've put 3 and 2 together in one group. And on the other side, they've changed the grouping. They've changed it to 3 on the outside of the parentheses and 2a inside. Whenever we change the group, but the answer stays the same, that is the associative property. All right. Moving on to part 2, solving single variable equations. Find the solution of each equation. Here we have 5x plus 9 equals negative 16. We will start by getting rid of the 9. It's added, so we subtract. We always do the opposite of whatever operation is taking place. We've added 9 to 5x. We need to get 5x by itself, so we subtract 9 from 5x. If we do that to one side, we have to do it to the other side. The 9's will cancel. They become 0. Which brings us down to 5x equal to negative 16, and negative 9 will be a negative 25. We then divide by 5 because 5 is multiplied times x. We want to undo multiplication, so we divide, and we divide by whatever's in front of x. So we divide by 5 this side, we divide by 5 as well. And when we do that, the 5's cancel on this side. X becomes a negative 5. Negative 25 divided by 5 will be 5, and the negative sign makes it negative. So, x is equal to negative 5. Number 13, 2/3 x minus 7 equals 5. Again, we need to get the x term by itself. So the first thing we'll do is we'll add a 7 to both sides. It's subtracted, so we do the opposite operation, which is addition. This will become a 0. Those will cancel. 2/3 x will equal 12. Now we have a fraction in front of x. And when we have a fraction, the common answer for dividing by a fraction is no. Instead, we do what? And that is multiply by the reciprocal, or we flip and multiply. So we take this, flip it over, and we multiply this side by 3 over 2. Well, if we do it to one side, we have to do it to the other, so 12 times 3 over 2 on the other side. Now the 3's become 1, the 2's become a 1, and so it leaves us with x on one side. So we have x is equal to 12 times 3 over 2. If we multiply 12 times 3, we have 36. 36 divided by 2 will be 18. So x equals 18 on number 13. Moving down the page here, we're going to have number 14, which is negative 8m plus 3m equal to 35. Now this is just simply combining like terms. We have a negative 8m, we have a positive 3m. So this will become a negative 5m when we put these together. That equals 35. We divide by a negative 5 on both sides because we divide by whatever's in front of the variable. That's a negative 5. Divide by negative 5 on that side as well. And these will cancel. M will simply equal 35 divided by negative 5, which is a negative 7. So M equals negative 7. Number 15. Again, we have several y terms that we can combine together and then try to solve for what y equals. We have 2y minus y. That's going to be 1